Hi there! Today we're going to be doing an experiment. First of all, you need a shot glass or a glass and some water. What we're going to do is fill the little glass with water. Doesn't have to be all the way to the top, but it does definitely help. Next, we place an index card on the top of the water. Now this is important. You have to make sure there's been a little bit of spillage to get a little indent on the top. Now, we're going to slowly flip the glass. See here, nice and flipped. Little air bubble at the top, that'll come in later. And then, remove your hand.
So why does this phenomenon happen? Well, the answer has to do with air pressure and the atmospheric pressure pushing upwards on the card from below while the water is pushing down on the top of the card. Here we can see the glass, the card, and also the air pressure. Looking at this drawing, we can see the gravitational force of the water pushing down on the card, as well as the force from the air pressure from below. Knowing that pressure is equal to force over unit area, we can say that the force pushing upwards on the card is equal to the pressure times the unit area. Now, if you've done the experiment correctly, there will be no movement of the water up or down. And if we take the card as y equals 0 in this case, we can determine that there is no net force in the y direction. However, this phenomenon might be more easily recognized if we consider the free body diagram here of the upside down water glass. First, let's identify all the forces acting on the system. First is the gravitational force from water. Second, we have a force due to air pressure in the top bubble above the upside down water. Finally, there's the force due to air pressure from below. Since we know the net force in the y direction of this system is equal to 0, we can derive the following equation. As we can see, there is a positive force acting on the water coming from below due to air pressure, and two negative forces acting downwards on the water. Rearranging this equation, we find that the force due to air pressure from below is equal to the sum of the force due to air pressure from above and the gravitational force from water. Next, we can consider Boyle's law and how it relates to the inverted glass of water. When the cup is inverted, the card sags, causing an increase in volume, and therefore the air bubble can now occupy more space. The result of this is a decrease in pressure at the top of the glass. This is illustrated in the pressure equation. As we see an increase in area, we see a decrease in pressure. Since the area has not changed, we know that this force must be less now than the force acting upwards on the glass, and that the pressure is less than 1 atmosphere.